bother. Okay, we'll continue now. Right, so the next thing now continues on naturally from the quadratic formula. Let's have a look at it. So if you can write this down, we're going to have a look at discriminant now. Now, if we have a look at the quadratic formula, we have x equals minus b plus minus square root b squared minus 4ac all over 2a. The most important part in this equation is this piece here. Yeah, because if it was positive, for example, it was a 9, then you have two values, plus or minus 3. If it was 0, then actually you really only have one value, because 0 and minus 0 is the same, so you only have one value. And if it worst was a negative, then you actually have no values, no real values. So the b squared minus 4ac tells us a lot about the quadratic. If the b squared minus 4ac is positive, then your quadratic has two roots. And so it probably looks like this on the graph. If the b squared minus 4ac equals 0, then it has one root. So it probably looks like this on the graph. And if the b squared minus 4ac is negative, then it has no roots. And it might look like this on the graph. So this is what it would be if it was 2, 1, and no roots. So because this is so important, it's given a name. It's called the discriminant. And we usually use the symbol delta to represent it. So this is what you might call the kind of key result or the key formula, what I have in the box here. So write this down, and we'll have a look at how this applies to some questions now. Okay, did you write that down? Nearly. I usually use delta, but I see sometimes books using a capital D for discriminant instead of delta, so that's fine as well. But I think most people use delta when they've seen this before. Yeah. Okay. Continue. Yeah. Continue. Yeah. So let's have a look at some examples. How many roots does minus 3x squared plus 6x plus 1 have? Now, I'm not asking for the roots. I just want to know how many roots, not what the roots are. So, discriminant is b squared minus 4ac, so that would be 6 squared minus 4 times minus 3 times 1. That's 36 plus 12, which is 48, which is positive. So since the discriminant is positive, that implies 2 roots. Nah. I mean, in the exam, you know, if I saw this and even this or that, it's probably enough. Okay, did you write that one down now? Yeah? Okay, if you can write that down, please. Just be careful. I'm not asking for the roots. I'm asking for how many roots. Okay, so in the exam, don't give the roots if they don't ask for it, okay? Because you might actually lose marks.
Might lose marks?
Yeah.
Negative marking?
No, not negative marking. You won't get full marks for the question. Okay, continue. Right. Yes? Yeah. Here's another one. Same idea. But I'm going to let you try it before I do it. How many roots does minus k x squared plus minus k minus 9 x plus 3 have? And the only thing, of course, I tell you is that k is not 0. Now, see, I don't tell you what the k is, but you might still be able to figure out how many roots this has. See if you can figure it out. Now, does anybody think they have an answer? Some people have answers? Or too tricky? Let's have a look. So if I want to know how many roots this has, I need to know what the discriminant is. Yeah? You think it has 2? No phones, off the phone. So if I want to know how many roots this has, I need to know what the discriminant is. So let's see what the discriminant is. So the discriminant is b squared minus 4ac. Okay, fine. But what's the b here? Minus k minus 9 squared minus 4 times minus k times 3. 4ac. Is this positive or negative? Positive, yeah. Why? Yeah, well, this is minus k minus 9 squared plus 12k. So this is positive, for sure. But it might be 0, and if it's 0, then it has no roots. It has 1 root. So, okay, it's at least positive, but it could be equal to 0. We need to check, could it actually be 0?
Well, you said it's not equal to 0.
Well, the only thing I said is the k is not equal to 0, but I never said if this necessarily. Like, at first glance, it looks like it could be 0, because if the k was 0, this would be gone. But if the k was 0, then this guy here would be 81. So that's no good. And if I tried to make this 0, then this piece here, it wouldn't be 0. Could I have both of these to be 0 at the same time? No. Because the only way this one could be 0... Yeah. And actually, that's a dirty lie. This actually... no. This is wrong. Why is what I'm saying a dirty, filthy lie? This isn't necessarily bigger than or equal to 0.
It's always bigger.
No.
Or it's either bigger or smaller. It's never 0.
Oh, yeah, okay, fair enough. But why is it wrong for me to say it's bigger than 0?
Because can't k be negative?
Yeah, k could be negative. So actually, even this is no good. Alright, so we've made little progress, but what's the next thing to do? I don't know if this is positive or negative yet, or 0.
Maybe you could expand?
Yeah, I think we should expand. So we'll get k squared plus 9k plus 9k plus 81 plus 12k. Now, is this positive or negative? No, we don't know because the k's could be negative. Do you know, if k was minus 100, this would be minus 900, minus 900. Yeah, so, what could we do next? Check. Oh, sorry, that's 30, is it? Now, is this positive or negative? Well, we don't know yet. Oh, sorry. Is this positive or negative? We still don't know if this is positive, negative, or 0. Well, I think there's one thing we can rule out. We can rule out it being 0. I think it's pretty clear that this can't be 0. So we know that one root is not possible. So it's either 2 roots or no roots. Yeah?
Maybe if you find the factor?
Not factorizing, no. No.
Maybe the square?
Yeah, that's possible, but there's something nicer to do.
But if you factorize, you get the roots, right? If you factorize, you don't get the roots.
Yeah, this.
Yeah, so you know whether or not it has 2 or...
No, but that's the roots of this discriminant, not the original equation.
Then you get
Yeah? Completing the square. Yeah.
But
Listen.
still, if you complete the square, you complete the square for this equation, not the first one.
I know this. What should happen? Did anyone complete the square here? Let's have a look. Let's have a look. Let's have a look. Oh, flip. Sorry, excuse my language. I just made a sign mistake in the question. Let me fix that. No, hang on. Trust me, it wouldn't have made you solve it. This should be a plus. So there's always a smart guy that says that. This should be a plus, which changes this to a plus, which makes this a plus. So let's fix that. Plus, minus, yeah?
How is that plus? That's
Minus.
Yeah, that's fine.
That's fine, isn't it? Minus 9 is minus 18. Minus 18 plus 12. Minus 6, isn't it? Yeah? Minus 6. Okay. Yeah, is it that now? Yeah. So this, positive or negative? Can you tell me now? No. Let's complete the square still. So what have I got here? K minus 3 squared, isn't it? Yeah, and then 81 minus 9, so what's that?
70.
Now is this positive or negative?
Always positive.
Always positive. So the discriminant is always positive, therefore 2 roots. Yeah, very hard. Very hard. I'll do another one like this.
Wait.
Don't worry, I'll leave it there for a minute.
No, I'm talking about like, how do you derive the fact that it's positive from the last equation?
You tell me. Look at it and tell me.
Square is always plus, whichever equal to 0.
Why am I saying it's always positive?
The vertex is 3 and 72.
Yeah, but
And it's a positive going up, so it's never going to go negative.
yeah, but it's a positive plus a positive. That's the way I think about it.
One vertex is 3 and 72. Sorry? The minimum is 3 and 72. The minimum
True.
is 3 and 72. So it can't go lower.
Do you have this? Ah, you went to the trouble of actually finding the roots.
No, not root, like finding the factor, what root.
And what factor did you get?
If I substitute minus 3, it will give me 0, so I got a factor of 8. I got k plus 3 as a factor of the equation.
Of the original equation.
Yeah.
Okay.
So, like, k is actually a negative number.
So if you got k plus 3 as a factor, then you know there's at least one root, maybe two.
No, there's not two. The other one, I don't think.
Hold on. There's at least one root, maybe two. So what you would need to check if k plus 3 is a factor is you need to check what the other factor is. Because if the other factor is also k plus 3, then you have only one root, because you have two factors that are the same. If the other factor is not k plus 3, then you actually, which is what it should be, then you have two roots then.
Yeah.
So no, I do like that. That works fine. So if you actually go to the trouble of finding the factors, that can be a little tricky to do. But if you got it, that's
I
good.
just substituted any number that could give me 0.
Yeah.
I put my
And you found something that gave you 0. Good, yeah. So now you'll have to do long division to get the other factor. Which we haven't done yet. But your method would work. It would work, yeah. Okay, yes. Huh? Yes. I'm going to do another example of this type. So watch carefully. Kx squared plus kx plus 4k. And there's only one thing we know about k at this moment. What's that?
It's not 0.
K is not 0. Okay. So the discriminant is minus b, which is minus k, plus or minus, oh, what am I doing? Sorry, I'm in the wrong mode. I'm in the wrong mode. B squared minus 4ac. Yep. So the discriminant is k squared, yeah? If I got all this right, b squared minus 4ac. Yeah, k squared minus, what's that? 16k squared. Now what's k squared minus 16k squared? Minus 15k squared. Now, positive, negative, 0, positive and 0, negative and 0, what have we got here? Negative and possibly 0?
No.
Because k is not 0.
Because k is not 0. So, what do we know about this quadratic?
No.
Never has roots, yeah. Yeah, I'll do another one, yeah. Okay, let's do another one here. One root. Yes. Yes, yeah, okay. Let's see. Okay. Right, have a look at this one now. Guys, look up. Wait, guys, I'm not going to talk over you. If you have a question, just ask me.
I have a question.
Yeah, go ahead.
How do we find out from that there's it's always less than 0.
Yeah, how do we know it's always negative? So what we have here, because k squared is always positive, k squared is always positive because it's a square, okay? And minus 15 is always negative because it's minus 15. So when you have a negative by a positive, it's always negative. So minus 15k squared is a negative number, meaning it's less than 0. It couldn't be 0 because for it to be 0, k would have to be 0, which we have as forbidden from the beginning. So it has to be negative, can't be 0, therefore no roots. Yeah?
But if the k is not equal to 0 wasn't there, then it could
Yeah, if you could have the k equal to 0, then your answer would be 0 or 1 root. It depends on the value of k. It'd be possible. It wouldn't be clear, is my point. Okay, another example of this. Minus kx squared plus 4kx minus 4k. Discriminant is b, which is 4k, squared minus 4ac. What's 4k squared? 16k squared. Minus minus minus? Yeah, what's that there? 16 k squared. So 0. So 0 means 1 root. But we still need the k to not be 0. I mean, this equation is quite bad if the k is 0, because what happened to the equation? It's all gone, isn't it? 0, 0, and 0. Okay, let's do a different type of question now.
So for this one we have 1 root?
Yeah. Because the discriminant is 0. Yeah? Can I scroll down? Yeah? Yeah, okay. Right, let's look at the reverse now. So, 2k plus 9 x squared plus minus 4k minus 4x plus 2k minus 6 has no real roots. Find k. So this is the opposite. I tell you how many roots it has, tell me something about k. So here I'm saying it has no real roots. Oh, and there's one condition on my k. What's that? Yeah, well, more precisely, 2k plus 9 is not equal to 0. Right? Because it's actually the thing in front of the x squared. So, k is not minus 9 over 2. Can you see how I went from there to there? Yeah. Okay. So we start this the same way, except we start with knowing what we should get at the end. No real roots, so what's the discriminant? It should be negative. Could it be 0? No. Negative. Alright, well, we know the formula for discriminant. It's b squared, so what's b squared here? That's minus 4k minus 4 squared minus 4, what's a? That's 2k plus 9, isn't it? And then the c is 2k minus 6. And that should be negative. Alright, well, you can guess what's happening next. What's happening next? Expand. Okay, so expanding. 16k squared plus 32k plus 16. Okay, so I've expanded the first one. If you have a little trouble with that, you can do it on the side of your notebook, because this here is just equal to minus 4k minus 4 times minus 4k minus 4, and you can multiply it out, and I'm sure you'll be left with that. Right? Yeah, that's right. Okay, now, next we have a choice. We can either multiply these first and then multiply by 4, or we can multiply these first and then multiply that answer by this one. It doesn't matter which way around you do it. I think what I'll do is I'll multiply these guys first, and I'll put the 4 in afterwards. Okay? So 2k by 2k, 4k squared. 2k by minus 6, minus 12, and then next, plus 18, isn't it? Minus 54, 9 by 6. Yeah? Now, next, 16k squared plus 32k plus 16 minus 4 times 4k squared, 6k minus 54. Oy, okay. 16k squared plus 32k plus 16 minus 16k squared minus 24k plus 216 less than 0. Okay, let's clean this up. Now, what cancels, which is very nice? K squared cancel, don't they? 16 and 16, gone and gone. 32 minus 24, is that 8k? 8k plus 232 less than 0. So that means 8k must be smaller than minus 232. Does 8 divide into that? I don't know. 36?
29.
29. K is less than minus 29. Say again? Listen. So look, the only way that this equation has no real roots, the only way that's possible is if k is smaller than minus 29. So if you pick any number smaller than minus 29, like minus 30, minus 31, minus 32, and you put that in here, you'll make a quadratic which has no real roots. Okay? So any value smaller than minus 29 back into this will make a quadratic that has no real roots. So k must be smaller than minus 29. Yeah.
So, like in the exam, if we put this as an answer and it says times 3.
Yeah, this is the best you can do. You can't actually get a k equals here because there's many values of k. It's anything smaller than minus 29 will do.
You have to write k is anything less than.
No. You could leave it like this, just. Yeah. It's a hard one. I know it is. Write this down, please. It's the hardest one today. Now they don't make it this hard in the exam, but you could get questions in the exam of the same idea, which is they tell you how many roots there are and they ask you to find the k. This is just the hardest one I could imagine. And the reason it's difficult is because there's lots of things to write out. But the idea is the same. You start with this, you put in your formula, and you simplify and you get the k at the end. I mean, there's no one step that's difficult, it's just there's a lot to write. Yeah. It's not like, what did I do here? I don't know how to multiply. It's just there's a lot to multiply, that's all. Okay, so write this down, and then once you have that, you can get started on your homework. So we'll keep it the same. first and last question. So A, Z, A, Z, A, Z.
So if we ever get into negative radical imaginary numbers, stuff like that.
We don't deal with that on this course. That's good, I think.
Good, because I don't like because you come back to this and then it's a mess.
It sure is. Where's my attendance sheet gone?
Yeah,
It's
I'm
in
looking
it.
for that as well.
Oh, there it is, there. I can close this. I can close.